Hello again. We're starting our unit on exponents. Graphing exponential functions will eventually come. And graphing exponential functions look like lines, except it's like somebody bends them into curves. That's probably the best way I can explain it without showing a picture. There, I showed a picture. That's not really going to do any good until we graph it though. So I kind of want to stay away from the pictures and just work on the properties for right now. And the first property that we're going to work with is the product of powers property. I'm going to do 4 examples really quickly and show you them, and then show you some arbitrary cases where they don't work. These ones work, but I'm going to show you mistakes that students usually make. So let's start with the first one. I've got x to the third times x to the second. And I want to figure out what that is, or I want to simplify that. Well, if I write out x to the third in longhand, it's x times x times x. And then I've got a multiplication symbol in between. And x to the second is x times x. 1, 2, 3, 4, 5. I've got x to the fifth. Now some of you might already know what I'm going at here, but I'm not going to explain it just yet. I just want to do these problems first. So I've got 3 to the third times 3 to the second. This time, instead of using variables, I'm going to use numbers. And in this case, variables are actually easier than numbers. So 3 to the third, pardon me, is 3 times 3 times 3. It's not 9, it's 3 times 3 times 3. Times 3 to the second, which is 3 times 3. Which is 3 to the fifth. But if you can do that, if you can do it in your head, or you can plug it into a calculator without giving you a number in scientific notation, I would expect you to simplify it. I would expect you to tell me what 3 to the fifth is, which is not 15, by the way. It's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, times 3, which is 243. So on numbers, you should go a step further. You should simplify it. On variables, you can't go any further. Next one is x times x to the fourth. And the reason why I do this one is because sometimes students get confused. Well, x is the same thing as x to the first. Well, that doesn't make a difference. I already know that. Yes, you do. But when you're going to eventually apply the property, maybe you won't. So it's good to reinforce that. So I got x times x to the fourth is 4 more x's. Woo! It's x to the fifth again. Go figure. And negative 4 to the third, or excuse me, quantity of negative 4 to the third times quantity of negative 4 to the second is, here's what I tell my students. You saw it with the quantity, make sure you keep it with the quantity. Because students don't put that down, and later on, if there were a different type of problem, they would mess up and get it wrong. Times the quantity of negative 4 to the second is 2 more negative 4's. And you're not going to leave it as quantity of negative 4, 1, 2, 3, 4, 5. What you're going to do is you're going to simplify it. And negative 4, a negative times a negative times a negative times a negative times a negative is negative. That's a positive, positive with another one, negative. 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1,024. So that's your answer. Now, the reason why I showed you this one specifically is so that you can figure out what's going on. When you've got a base, when you've got the same base, and you're multiplying them, let me say this again. So these are both the same. The x's are both the same, and you're multiplying them, and they both have exponents. All you really have to do is rewrite it as x to the third plus 2. But that's kind of confusing, so what I tell my students is, if you see a multiplication sign in between 2 bases, and the bases are the same, you just add the exponents. 3 plus 2 is 5. 3 plus 2 is 5. Then simplify 3 to the fifth. 1 plus 4 is 5. You can't simplify it. 3 plus 2 is 5. Evaluate it if you can, which you could. Now where students get tricked on is this. They see this example, x to the third plus x to the second, and they think it's x to the fifth. No, there has to be a multiplication sign in between them, not an addition. Oh, well, what is this? This is the answer. You can't simplify it. If you knew factoring, then you could factor it, but we haven't done factoring yet, so don't worry about that yet. Another example students might see, get confused, is they say, okay, what about if it's like this? X to the third times y to the second. That's x, y to the fifth. No, it's not. The bases have to be the same when you're multiplying. You can't do anything with this. Well, technically you can just make it x to the third, y to the second. But the bases have to be the same. X and y aren't the same base. They have to be the same. And there has to be a multiplication sign. Well, this has a multiplication sign, but the bases aren't the same. Bases are the same, but it's not a multiplication sign. So in this case, you can't simplify it any further, and in this case, you can't really simplify it any further either. This one with factoring, we'll get to later. So that's a basic understanding of product of powers property. Multiplication sign in between both, and even if I didn't put that, that's technically a multiplication sign too. It reads quantity of -4 to the third times quantity of -4 to the second. That's also a multiplication sign. And the bases have to be the same. That's the overview. Have a good day for now. Bye.